Hello everyone, welcome to today's stream of Codeforces Educational Round 185. Let's start with the first problem. So in the first problem, we are given a n cross n grid filled with numbers as follows. The first row contains integers from 1 to n, second row contains integers from n plus 1 to 2n, and the nth row contains integers from n square minus n plus 1 to n square. So grid is as such 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's because it is a 4 cross 4 grid, so all the numbers are arranged in ascending order. If it had been 5 cross 5, then 1, 2, 3, 4, 5 was in first row, and so on. What we need to find? Uh, we need to find the maximum cost among all cells. And how is cost defined? You can choose a center point, and then all of the immediate neighbors, select them and add their values. That value is known as cost, and we want the maximum cost. So um, we would always want that the largest numbers are in our array, alright? Because this is our matrix. For any given matrix, we would want that the largest part are these are in our matrix. Alright, but if we want to include all the top three largest part, we need to sacrifice one of the neighbors. Alright, if we had shifted this by one, that is, instead of this selection, we had selected this. We had selected this, we would have 5 numbers, while in the yellow selection, this one, we have only 1, 2, 3, and 4 numbers, while in this selection, we have 5 numbers. Alright. So the max of these two selections will always give us the answer. So let's uh, analyze it. In this, we have all the largest number that we can get with this same. And in this, we have all the largest numbers sacrificing one number. Alright. And uh, is there any other possible case that might exist? Yes, this shape. But in this shape, the answer will always be smaller than the yellow shape. Why? Because yellow shape include both of these and one extra number, right? Here it was 12 and here it was 14. So always yellow shape will give us the larger answer. So considering only these two shape will lead us to the answer. Alright, so let's go implement it. So in each case, this shape would never exist for 2 cross 2 grid. Alright, so for 1 and 2 cross 2 grid, let's hard code it. Alright, so if n equals to 1 or n equals to 2. Answer is given to us in the test case. So let's copy it from the test case itself. Okay. And what about the rest cases? The answer is this case. This case. Let's write the center as n square minus 1. And what are the numbers that we are including? Center itself, center plus 1, center minus 1, center minus n. Because this is 15 minus 4, 11. Now center for the second shape, red shape, is n square minus n minus 1. Alright, so answer is equal to max of answer comma center itself, center plus 1, center minus 1, center plus n, center minus 1. Alright, and answer, and this is it. Now let's move to the second problem. It is addition on a segment. Uh, you are given with the array which consists of zeros initially, and we have to apply exactly n operations. Operation says choose L and R and assign every element in L to R by 1. Alright, increase it by 1. Now it is given that answer always exists, and we are also given uh, array B, to which we have to transform our current array. Now, what are the restrictions? First, the number of operations performed should be exactly equal to n, and we want to find the maximum value of L minus R plus 1 over all the action performs is as large as possible. Alright, we want this R minus L plus 1 to be as max as possible for only one operation. Alright, so for one operation, if we want to maximize it, what do we want? That maximum number of operations are performed, maximum number of ranges are covered in one operation, while for the rest of the operations, we can just choose the smallest range itself. Alright, we can choose just increment by 1 in range of length 1. Alright, so because we need to minimize the values increased in second and fourth steps. Alright, second, third, fourth steps. We want the first step should contain the range as large as possible. Alright, so what should we do for it? Note that we have some numbers. Alright, if we cannot apply operations on zeros, alright, let's have some numbers. Alright, we have, let's say, 7 operations. Now, what is the best? We need to waste our n minus 1 operations at any cost. So how to waste it? Just apply one operation on one length. We can waste 4 operations here, making this 1. Alright, leaving this 1 as an element for that largest operation. Alright, here also we can waste 2 operations. Alright, because this is 3 and leaving it 1. Here we cannot waste any. Here also we can waste 2. And if all the wasted values, operations, wasted lengths still is not equal to n minus 1, because in one operation we have to at least increase by 1, and wasted value is still smaller than equal to n minus 1. Then we need to apply those operations on these ones at the end. Alright, so if that is the case, then answer is equal to total length. Just remove these zeros. The positive numbers are total length minus the difference between these, the number of ones we need to waste to get wasted value up to n minus 1. Right. Else, we can just waste all the elements, keeping this first operation, that is the largest operation, as large as possible. So it is equal to total length itself. So let's go on implement this problem. So we have this array. Let's calculate the sum. Sum denotes the wasted length. Right. If so, have the count of all the zeros, because zeros are elements on which operation cannot be performed. So sum is current vector minus 1. The current element is not equal to 0, else count plus plus. Correct. At the end, our if our sum is greater than equal to n minus 1, then just print n minus count. Alright. And if it is not, we just need to waste some more ones is equal to n minus 1 minus sum. Alright, this is it. Alright, this is minus instead of plus because that many operations we need to subtract extra. Alright, so let's move to the third problem now. So the third problem states that we are given two integer arrays q and r as well as an integer k. Now we need to perform the following operation any number of times. What is the operation? Choose two integers x and y such that y is smaller than x, strictly smaller than x. There exists index I such that qi in the first array it is equal to x divided by y float, and there exists an index j such that rj is equal to x modulo y. Alright, now remove that qi from q array and rj from r array. If there are multiple occurrences, just remove one. Now we need to calculate the maximum number of operations we can perform on the given arrays q and r. Alright, so let's analyze this. So what is qi represented by? What do we get qi by? It is we got it by floor of x divided by y. And ri as x modulo y. So whatever x is uh, it can be represented by k times y plus ri. Alright, because we want mod to be ri, so and y is equal to uh, the chosen value, so ri can be represented by, like x can be represented by some element multiplied by y plus ri, which is the remainder. Alright, now what should be the value of y so that this ri is valid? Alright, if this ri is smaller than y, then it is valid. If it is greater than y, then it is not actually a reminder. All right, because this means that 5 reminder with 2 is always smaller than 2. All right, so this y value should be greater than ri itself. All right. So for a given ri, let's say we choose a ri. What is the let's say maximum number of qi we can get? What is the range of qis that are possible? All right, so x is a times y plus ri. All right, and y is greater than ri. So what is x by y? What is the maximum value of q we can get? Or what is the constraint? Is equal to x divided by y, which is k into y plus Ri divided by some number greater than Ri. Right? Ri plus 1, let's say, Ri plus Z, let's say. Alright. And this x by y term is Qi. Alright. This term is Qi. So what is the constraint in this Qi we got from a given Ri? Can we always get Qi as 1 or 0, let's say? How? Just choose a number smaller than Ri plus 1 as numerator. Okay. Ri can be as small as 1. So Ri plus 1 is the smallest denominator we can get, which is 2. We chose the upper number as 1. Then obviously we get 0 value. So the lower limit is 0, let's say, or because the requirement is always greater than 1, greater than equal to 1. So let's say lower limit is 1. So now what about the upper limit? For upper limit, the denominator should be as small as possible and numerator should be as large as possible. Alright. So numerator should be as large as possible. So what is the maximum number we can get of x? X is smaller than equal to a. Alright. So this particular thing will also be smaller than equal to k. Alright. So what about a into y? This term is smaller than equal to k minus ri. Alright. Now we know that this term will be not considered in floor value. Alright. So let's just consider this term. So a minus ri divided by the largest number, smallest denominator we can get, which is ri plus 1. This is our maximum limit on qi we can get. Alright. What if we increase some ri? If we increase ri, our um, numerator decreases, alright, and denominator increases. Why? Because the positive number is subtracted, so numerator decreases, and ri itself increases, so denominator increases. So value of qi, upper bound, decreases. Alright. So for starting, what will be our desired algorithm? We want the maximum number of matchings. So we would want to match each and every qi. So for smallest, starting from the smallest qi, try to match the largest possible starting from the smallest ri. Try to match the largest qi. Alright. And continue this process to get all the matchings and count the maximum number of matchings. Alright. So for this, let's qi and ri as input. Now sort all the QIs and RIs. Now we want the largest QI to match with the smallest Ri. Alright. So I take it over from the smallest Ri. Alright. Now what is the maximum limit for this thing? Let's say it is val, and val is equal to a minus Ri divided by Ri plus 1. This is the maximum limit. Take k as input as well. Now while our current value is smaller than the Qi, our Qi should decrease. Right? And once this condition is false, that is our value is enough to satisfy this particular Qi. Ri is greater than 0. If Ri is greater than 0, that means there exists some Qi is greater than 0. That means there exists some valid Qi, valid index greater than equal to 0. Alright. Then our answer will be increased by 1 at the end. Print the answer. Okay, we forgot to check the restriction on the value of Qi. It should always be greater than 0. Here also, if Qi is greater than equal to 0, then only. So now the test cases are passed. So let's move to the next problem, which is the 8th problem. So in this problem, we define a block in a binary string as continuous substring of characters of same time that cannot be extended either to the left or right. For example, in this string, there are 3 blocks, that is continuous ones, 1, continuous zeros, second block, continuous ones, third block. Okay? So these are the 3 possible blocks. Okay. Now, you can understand more about what block is by reading this. Now, we call a string beautiful if we can remove exactly one block from it so that the resulting string consists of an odd number of blocks. For example, this string is beautiful because we can remove the block from third to the fifth character. How? Third to the fifth, now only one block remains. Alright. So now what is our task? We are given a string of, we are not actually given string, we are given an integer n, and we are given m constraints, the ith of which says that in the string which we want to construct, the string li to ri should be beautiful. Alright, substring li to ri should be beautiful. This should be valid for each of the 1 to m constraints we are given. So first analyze what a beautiful string is. Alright, so if beautiful string can be transformed to string of odd blocks by deleting one block. Now let's see for odd sized block, that is there are 3 blocks, let's say. Alright, if there is 1 block, then we need to remove that uh, particular block, because we need to remove at least 1 block. So 0 blocks are left. So not possible. Now for let's say 111 000 111, which is having 3 blocks. Now if we remove this middle 0 0 zeros, all right, then 1111s are only left. All right, so 1 block is reduced because all zeros are reduced, and 1 block is reduced because these ones and these ones become 1 block now. So this leads us to 1 block, which is odd again. Similarly, if there are 5 blocks, we can just remove the first consecutive uh, second block. All right, we can remove the second block, and the first and third block are combined to a single block later on. So for values greater than equal to 3, always possible, right? So, but for value 1, it is not possible. Now for even blocks, let's say we have 2 blocks, all right, then 1 1 1 1 0 0 0 0. Just remove the first block. You always get even number of blocks because we removed 1 block. So always possible. So what did we got? We got that our substring should not be block of size 1. All right, that is, our substring should not contain only ones or only zeros. All right, so let's, what is our new problem now? Find a substring such that all the required substrings do not contain only ones, only zeros. All right, so what to do for it? So first understand one thing. Let's say this is the number line. Let's say this is the number line. All right, now if we are given range L1 R1 and range L2 R2, all right, then is considering this range good? I don't think so, because this range says the same thing. All right, it says that all the values should not be 1111s or 0 0 0 0s. And this says, this L1 to R1 range says this range do not contain values 1111 or 0 0 0 0. And this L2 is a substring of this. So L2 says the same thing as L1. If L2 is true, that is the range 2 is true, then range 1 is true as well. Range 2 is true implies range 1 is true. So why are we considering this? Because we want to avoid extra calculations. All right, let's say we just first set the number of places where we want to calculate the number of places where for this range contains only 1111s. Then if we have already processed L2 to R2, then processing L1 to R1 will gives us same cases. All right, extra counting of cases will be there. So we want to get rid of such cases where one range is contained inside other range. Now, so for this thing, what do? We keep for each I, Ri, that is I as endpoint of a range. If a range has smaller endpoint and larger starting point, then no need to process. Now let's say we have, if let's say we have range, let's say we have this substring, all right, and for anyhow we have computed until this j, all right, we have computed for this substring, that is what are the number of ways by which we can have a valid string construction of length j such that all the ranges are satisfied, and we see that we are given a range from L to R. Let's say this is L and this is R. Then this range should not contain all ones and all zero or all zeros. All right. So what should be subtracted now? Like this is the range where we have the number of possible values for prefix from 0 to j. So this, the first case that should not be there is all ones, or the case this is 0 and all ones, or the third case, alright, this is 0 0 and let's say this was the starting L, then all ones or all zeros for this range or for this range should not be there. Alright, so we need to subtract these cases for R and L's for every R we want. So let's create a DP. Of I represent number of ways for a prefix. Like let's understand one thing. Like if we are considering this thing, alright, this particular scenario or this particular scenario, the string is same. So we want to avoid overcounting. Alright. So we need to do something so that if only this particular value is changed, then we need to consider. Alright. If all zeros, that is the first digit and the second digit are same, that is this particular scenario, then this scenario, and where our j is from here. Alright, we calculated the number of ways starting from this j, then from j plus 1, and this was 0 itself. Then we calculated one extra way, filling all these with zeros. So this is an extra counting. So we want this to change from previous. So we define our DP state as number of ways for filling prefix I li with a valid way such last change occur at I. Alright, this saves us from extra cases. So now let's say we have answer up till j, then we can calculate answer up till r by uh, cases where these values repeat. Alright, repeats as the same. Say repeating starts from here or here. If it starts from L plus 1, then we have no problem, alright, because uh, 1 and 0, there is a difference here. That is, there is a change that all not all values are ones, not all values are zeros. So that is it. Now implement this thing, calculate all the values in answer value, and if we got a range, then we need to subtract the ranges where uh, this range contains all ones. So calculate those range and print the final answer. Let's uh, do it in a code. So what do we have? We have n and m let's say we want all the ranges to be stored. So create a vector pair ranges. Create a max array. Alright, this defines maximum. We wanted these type of ranges to be avoided. Alright, so for every R, calculate the maximum L. So this R corresponds to this range. Alright, like this is shifted like this. Alright, so same scenario. So let's take the input. So this in Excel represent what is the maximum up till this R. Alright, if the max is this L1, then consider this L1 as the starting index for this range as well. So no operation need to be applied now. Iterate for m values that we want to input. Now take L and R as input. Okay, this is one based, so first convert to zero based and push it in range. Now max L, how should this vary? Max L of R is equal to max L at R, comma max L at current index. Okay, what is the current index max L? It is L itself. Alright. Now create this max value for all the R's possible. So iterate over all the values of R's, create it like a prefix max. Max with previous element. Comma, what is the max value of current element? So we have avoided such ranges now, which uh, leaded to problems. So for the first value, we need not compute for array of length 1. Initially, the answer will be 1 without removing any ranges, the computation. Now, what is the previous value up to which range we have computed, and the last range value of that is the R value of the last range processed. Create a DP as the same state as discussed earlier. Now DP of 0 will be 2 again, because now what is the number of ways such that value changes. 0 change a value, 1 change a value, so 2 ways, and it is a valid way. Alright. Iterate from first index up till the last index. What is the left max we want? It is max L. Now create DP value. DP value is answer up till this point, because value changes at current point. So so we do not have option, right? Like if the past value was 0, it should be 1. We have no option. In the other case, answer is can be anything. Like answer we are computing, it is filling all the values with zeros or ones, minus all the invalid cases. All right, invalid cases will be computed with the help of TP. Now since we want modulate with M. Now while the previous value, that is previous computed range, is smaller than equal to the current L, that is current range is L, then we need to remove cases of 0, 0, 0, 0, then from this index 0, 0, 0, 0, every index starting from a prev up till L. Alright, so while our prev is smaller than equal to L, subtract the extra counted cases. Now pref plus plus at the end, print the answer. Alright. Okay, we did not change the value of mod up here. It is not 29 plus 7, it is 9924. And yes, our solution is passed. So this is it for today. All the best for upcoming contests.